Hello everyone, welcome back. This is Engineer Hussein Mosapi. So in this video, we'll be looking at how to find the domain of any function. But before we begin, don't forget to like and subscribe to the channel. Alright, let's get to it. Now, we need to understand firstly that a function is defined to be a set that contains inputs, which are the x values, and outputs. The outputs are regarded to be the y values. Now, once you understand this, you need to also understand that if you look at the term domain, the domain is simply just defined as all possible x values. Now, when you say all possible x values, we're talking about all possible input values. Now, these possible input values shouldn't make the function undefined, which means that we should never have a case where we have 0 at the bottom of the root or the root of a negative number. So, we're looking at all possible x values that makes the function defined. So the whole goal is to look for values of x that will make the function defined. This is basically the knowledge about the domain. Now, every time you're looking at the domain, you need to understand that the domain is entirely dependent on the type of function that you possess. So we have different conditions that depend with the type of function you have. For instance, let's look at the first type. The first type of functions we look at are regarded to be polynomial functions. Now, whenever we're looking at polynomial functions, we're looking at functions, say you have something like f of x is equal to ax to the n plus or minus bx to the n plus or minus cx to the n, and it keeps on going like that. So whenever you have a condition like this, you can also have a plus or minus in front to the coefficient of the x to the n in the first portion here. Whenever you have something that looks like this, be mindful that for every polynomial function, the domain will simply just be all real numbers. All real numbers. Now, when I say all real numbers, you need to understand that we have different ways in which we can represent the domain of a given function. Like in this case, if I choose to use the inequality notation, it implies that I'll be looking at a condition where I have something like this. So, using the inequality notation, what happens is that I will say that my domain, therefore, will be, I open braces, will be a condition where x should be a member of all real numbers. So this is an inequality notation. But there's another notation or another way you can write the domain, and that way is called the interval notation. Now, using the interval notation, the domain will therefore be, now since we're saying it's all real numbers, and real numbers will span from minus infinity to positive infinity, which means that I will have from minus infinity to positive what? Infinity. Now, you need to understand that when it comes to interval notation, you will expect to find two types of brackets. You will have the normal brackets, which are also referred to as parentheses, and you also have the square brackets like that. Now, the normal brackets, also referred to as a parenthesis on a graph, will always show an open hole. So you have an open hole like that. But for a square bracket on the graph, it will always show a closed hole. Now, this means that whenever you have the parenthesis, it means that that value is not included. But in a case where you have square brackets, it means that that value is simply what? Included. So we're not including negative infinity or positive infinity simply because we don't really know where numbers start from or end. But we're looking for a list of all real numbers, all possible x values we can ever think about that will always make the function defined. So which means we're looking at all numbers we can think about, provided that they're real. When it comes to the number system, you need to remember that we have imaginary numbers and real numbers. Now, when we say all real numbers, it means that we're not going to consider imaginary numbers, numbers that will have I. Let's say the root of negative something will always give you something I, which is imaginary. So we're trying to avoid that aspect when it comes to listing domain values for all polynomial functions. So remember, we have the inequality notation and the interval notation. For the interval notation, I might be using some acronym just to avoid writing the entire word as IN. That's interval notation. Then for the inequality notation, I'll be using the acronyms, which will be, it's going to be the same thing, but I'll just say I, E, then dot N. To say inequality notation. And this would be the interval notation. Literally, in will be for interval and E sub E, then N. That would be for inequality notation. Alright, let's understand this clearly with another type of function that we might have. So in the next part, we'll be looking at a condition where you have fractions only. Now, we know a fraction is defined to be a part of a whole thing. So whenever you have a function, say f of x is equal to a over what? B. Now, you need to understand that where a and b can be what? Polynomials. But at times, even a could be a constant and the bottom will be the polynomial. So now, how do you go about solving or finding a domain for fractions? So to find the domain for all fractions, all you have to do is to set the bottom to not equal to 0. So set bottom to not equal 0. Once you do that, then you would find all the domain values that you need. Let's look at examples. Say you've been asked to find the domain of f of x is equal to 2 over x plus 1. So we're trying to avoid finding that value, that which if I add or plug in for x will give me a 0 at the bottom. So by inspection, we know that's minus 1. So what we're going to do is just to say, if I set the bottom not equal to 0, the bottom one I'm having is x plus 1, and this should not equal to 0. Then you solve for x. X should not equal to minus what? 1. So you now have the domain. Now remember that the domain can be written in two ways. We have the inequality notation and the interval notation. Using the inequality notation, we will say, open braces, that x should be a member of all real numbers such that x should not equal minus 1. That's how you read this. X is a member of all real numbers such that x is not equal to minus what? 1. That is for the inequality notation. For the interval notation, you will say the domain. Now, let's understand this clearly. We're saying that x can be anything rather than minus 1. So, if I had to show this on a graph, if I had that, we know that this is from negative infinity and that's to positive what? Infinity. We don't want x to be what? Minus 1. So remember, it's going to be what? An open hole. We don't want to include the minus 1. So it means that x can be anything from minus infinity but not 1. And from minus 1 to positive what? Infinity. Which means that if I use the interval notation, it will start from what? Remember, it's starting from what? Minus infinity, going to the minus 1. So it's going to be from negative infinity up to minus 1. But again, it will span from -1 to what? Positive infinity. And this will be the domain for that value. So looking at all possible x values, and all those possible x values that will make the function defined will come from negative infinity to -1, which is not including 1, as you can see. Then from -1 to positive what? Infinity. Let's look at another example. Say we have f of x is equal to 2x plus 1 over x squared, let's say plus, no, say minus 4. Alright, so the first thing we're supposed to do is to set the bottom not equal to 0. So if I set the bottom not equal to 0, my bottom is x squared minus what? 4, and this should never be 0. So if I solve for x, it means that x squared should not equal to 4. We know that we have to root both ends, so x should not equal to positive 2, or x should not equal to minus 2. Now, using the interval notation, this implies that what I will have is that the domain will simply be a condition where x should be a member of all real numbers, such that x should not equal to positive 2, or x should not equal to minus what? 2. That is the notation. Now, using the interval notation, unlike the inequality notation, for the interval notation, I first have to graph this. So I just, not even graph, just to draw a number line and try and predict or understand what's going on. So I have minus 2 there, and I have plus 2 there. So I don't want x to be minus 2 or plus 2. So I'm not going to include minus 2, and neither am I going to include the positive 2. So x, let me just do that. So x can come from negative infinity, like that, but never be minus 2. Again, it can come from minus 2 going to positive 2, but not being 2. And from 2 to positive what? Infinity, like that. So this means that with the interval notation, I'll say that my domain will simply run from minus infinity to minus 2, not including 2. Then not including 2 to positive 2, and not including positive 2 to positive infinity. So this is the domain for the given function in interval notation. So basically, whenever you have a fraction type of function, always set the bottom to not equal to what? 0. Alright, let's move on to the next type of function. So in the next type, which is 3, is learning how to find the domain where you have been given a root only. So in the case where you have the root only, what do? So imagine you have a function, say f of x is equal to the nth root of the radicand. Now in this case, whenever we want to find the domain, we need to understand that we have to set the radicand to be greater than or equal to 0, because always under the root we're trying to make sure that we don't get negative numbers, because whenever you get a negative number under the root, that number system will change from real to imaginary. So let's put that in mind. Now we'll understand this with a few examples. So let's imagine that we've been told to find the domain of the following functions. So we have f of x is equal to the root of the square, to be precise, of x plus 1. Now remember, we're trying to avoid having negative numbers here. So what is our domain? So using the inequality, before I even use the notations, let's try and set the radicand to be greater than or equal to 0. So the radicand I'm having is this, and my radicand is x plus 1. This should be greater than or equal to what? 0. I will solve for x because this is an inequation, so this is going to be x. You find that x will be greater than minus what? 1. So once you have that, you need to understand that the domain, or the x values here, are all the numbers that are greater than or equal to minus 1. So using the inequality notation, I will say that my domain should be in the case where I would say x should be a member of all real numbers, such that x should be greater than or equal to minus 1. That's how you write it, like that. But in the case where I want to use interval notation, my domain will be, I have to make a simple sketch, so that's my minus 1 there. So since it's greater than or equal to, one thing you should understand is that when it comes to inequality signs, when you have, when you have greater than or less than, be mindful that this is not including. But when you have greater than or equal to, or less than or equal to, be mindful that this is what? Including. So in this case, we're including. And when it comes to inclusion, we always put a closed what? Hole. So I include in minus 1 and everything greater than it. So all values that end, that is towards positive what? Infinity, and away from negative infinity. So this means that we're looking at a case where we include minus 1 and go all the way to positive infinity. Now, we don't really know where positive infinity is, so we can't include that number because we don't know it. So parenthesis like that. So this is basically our domain. Now in the case where we have more values of x, say we have h of x is equal to the root of x squared minus 4. In this case, we'll do the same thing, set the radicand, which is x squared minus 4, to be greater than or equal to what? 0. We solve for x. We know that this would be x squared being greater than or equal to 4. Then if you introduce the root, you have x is greater than or equal to positive 2, or x is greater than or equal to what? Minus 2. Now, using the inequality notation, we'll say that the domain is a situation where we say x should be a member of all real numbers such that x should be greater than or equal to 2, or x should be greater than or equal to minus what? 2. With the interval notation, the domain will be a situation where you have to first what? Graph the given quadratic function. Now you know that the values is actually, you have minus 2 and positive what? 2, which means that the graph is cutting the x-axis at the values of x you have found. So looking at the nature of the coefficient of the x squared term, you find that a in this case is positive, and if it's positive, it means that it's opening what? Upwards, like that. Or you say it's smiling, most people like to say. Then if it was negative, it will go the other way, like that. Yeah. So in this case, I'm trying to avoid to get the values that are in between there. These are the values we don't want. So I'm looking for all the values this side and that side. It could also include these numbers here. This means that I will start all the way from minus infinity, because this side we have minus infinity and that side we have positive infinity. So I'll start all the way from minus infinity, then include minus 2, or a case where I now include 2 towards positive infinity. And that is simply what? My domain. So let's not forget that. So that's literally how you go about solving questions like this, where you have to find a domain. What you have to do is to graph it and then estimate the values of x that you have. Do a bit of some sketch and you will find your value. Let's move on to the next type. Alright, in the next condition, that's where we have the square root at the bottom of a fraction. In short, when we have the square root as the denominator, let's say you have a function f of x is equal to something, which is a polynomial function, over the root of what? Something. That's the case. So in a case where we have such, all we're supposed to do is to set the radicand to be greater than 0. So domain implies that the radicand should be greater than 0. Let's understand this with an example. Say we have a condition where we have function f of x, let's say it's equal to x to the power 3 plus 1 over the root of x plus 1. So we set the radicand, which is x plus 1, to simply be greater than 0. So for x is greater than minus 1. Once we do that, all we're supposed to do is to now write the domain values. We can use the inequality notation, where we say domain will be that x should be a member of all real numbers such that x should be greater than minus what? 1. In a case where I want to use the interval notation, for the interval notation, we need to understand that graphically this could be, you have the minus 1 there. So we're not really including, because that is just greater. It's not greater than or equal to. So this means that I'm not including the minus 1, but I want everything that is greater than minus 1. So it means that the domain will simply be from minus 1 to positive what? Infinity. I'm not including minus 1, and I'm not including positive infinity. So this is the domain. Let's move on to the last condition. Now in the last condition, what we might have is that we might have a square root on top of a fraction. Say you have f of x to be equal to the root of something over something. What's the case? So in this case, you have to apply two conditions. Make sure that the radicand is greater than or equal to 0, and that the bottom is not equal to 0. Whatever values you get, find the intersection. Let me explain with an example or examples. Say you have a function f of x, and this function is equal to the root of x plus 1 over x squared minus what? 4. So I need to make sure that the radicand, which is x plus 1, is greater than or equal to 0. So this would be x being greater than or equal to minus 1. So I have that condition. Then I have to make sure that the bottom, x squared minus 4, is not equal to what? 0. So this means that x should not equal to, x squared, sorry, should not equal to 4. Therefore, x should not equal to 2 if we solve the equation. Or x should not equal to minus what? 2. Using the inequality notation, the domain will say x should be a member of all real numbers such that x should be greater than or equal to minus 1. We say, or x should not equal to 2, or x should not equal to minus what? 2. And that's how you write it. Now, what if I want to write the same thing in interval notation? Let me erase this. Now, in interval notation, what we're supposed to do is to first make the plane, x or y plane. So x, we have the minus 1, so we have minus 1. We also have minus 2, and we have positive what? 2. It's including minus what? 1. So here it's including. But on minus 2, let me put the inclusion on top, a bit on top there. but it should not be 2 or minus 2. So it's not including these two values. So ho. So I have minus infinity to positive infinity. Now it's saying that you need to find the intersection. So let's look at the first condition. X should be greater than or equal to minus 1. So anything greater than or equal to minus 1 goes in that direction. But for this condition, it means that it can be anything from negative infinity but there, or from there to that point, or that point going all the way to positive infinity. So in finding the intersection, you just find where the lines meet. So I'll do that. I extend it there, and I also extend it everywhere, and it goes on like that. So my intersection is here, like that. So which means that in interval notation, my domain will just start from the inclusion of minus what? 1. To what? It's not including 2, so it's not including 2 there. So it will be 2, not including, or from 2 to what? Positive infinity. Like that. Let's look at another example. Say we have a condition where we have h of x being equal to the root of x plus 4 over x squared minus 4. So the radicand, which is x plus 4, should be greater than or equal to what? 0. So x should be greater than or equal to what? Minus 4. Then x squared minus 4 should not be equal to 0. So now this would be x should not equal to 2, or x should not equal to minus what? 2. According to the inequality notation, the domain will be that x should be a member of all real numbers such that x should be greater than or equal to minus 4. Let me use union. Then x should not equal to 2, or x should not equal to minus 2, like that. Then using the interval notation, all you have to do understand is that if you put this in a simple illustration, you have minus 4 there, you have minus 2 there, and you have positive 2. It's including minus 4. It's not including minus 2 or that one there. So it could be anything except that, but it could be that except that, and it could be that, the positive infinity side. Then we're saying that it should be greater than or equal to minus 4, so anything great is in that direction. So supposed to consider the intersection. So all these going that way. So this means that if I apply in interval notation, my domain will be include minus 4 to minus 2, in union of minus 2 to 2, in union of 2 to positive what? Infinity. And that is the domain. Alright, so that's how you go about finding the domain of these conditions. Might be a bit tricky at first glance, but with a bit of some practice, you get the hang of it. Thanks for watching. If you have questions, you can always reach me on WhatsApp on the line 077 149 5252. Alright, slow progress is better than no progress, and remember to strategize before becoming a statistic. Let's try to push for that A+.